Hey. All right, folks, we're going to do the activity is called virtual noon sun angle. And I'm assuming at this point we've opened it up from Canvas and you're in Kami. Kami would be exceptionally easier to do this assignment on. So if you can open that, that'd be the best. I'm going to move my face over here. I think right there should do the trick. And the first thing I want to do is I want to draw photons of light from the sun, light rays coming from the sun. And it's important to note that in this activity we're doing, the sun is always on the right side. So doesn't matter what day we're doing. Here's April 22nd. Here's May 22nd. The sun is always on the right side. Okay. Now it's a little confusing because obviously the Earth orbits the sun, and so if the sun is always on the right side, we are we're going to only see that perspective of the Earth from the sun being on the right. Okay, so that being said, I'm just going to make a note right here that the sun is over here. I'm going to pick yellow. Okay, and I'm going to say, oh, here we go. I'm going to say, okay, size 18. Let's go big. Say sun. S-U-N, of course, as we've established in the past. So somewhere way off to the right, 100 million miles or so. Okay, so the sun is coming from over there. All right. Now, if that's where the sun is, I can also make I can make a conclusion that if the sun is on the right side of this image here, then oops, I don't want yellow at this point. I would like a different color. If the sun is on, the left or the right side, then I know nighttime is going to be right here, right? This is going to be the division of night and day, right? And that means I can shade in this area as nighttime, but I really don't feel like doing that right now in terms of saving time. So everything on the left is nighttime, everything on the right is daytime. Now, here's the South Pole, here's the North Pole. Earth's rotating based on the axis, right? So portions of Earth are going to rotate in and out of daytime. Okay? Next thing I want you to do is go to shapes. I want you to get a straight line, and we're going to do a yellow straight line to represent photons of light from the sun. I'm going to make it a little bit bigger than it was before. And notice there's 4 lines of latitude that we're always going to use. So the same 4 lines come up every time. Okay? It's 23.5 degrees south, it's the equator, it's Detroit, and it's the Arctic Circle here, 66.5. Those are always the 4 that we're going to look at. What I want you to do is I want you to draw a straight line that is smacking into, notice I can make sure it's perfect because it actually tells me the degrees, right? I want it perfectly smacking into the Earth here, and I want it to be parallel to all the other photons of light from the sun. Okay, so what I'm doing is I'm just drawing photons of light, right, smacking into the Earth. All right, I'm going to keep it. Aha! Okay, so what we're doing is I'm trying to show you what the light is doing when it hits the surface of the Earth. Okay, next one I'm going to do is right here from the Arctic Circle up there. All right, so these are all photons of light hitting the Earth's surface. Okay, and I'm going to zoom in here. So we live at 42.5 degrees north latitude. Okay, if we were standing right here, right, straight up would be over here. So what I'm showing you here is that the sun on December 22nd at noon is nowhere near straight up. We'd have to look farther down to see it. So what we're going to do is we're going to recreate these angles right here, but do it from a more, down to earth perspective. That's what this part is right here. We're going to do the profile view. Okay. So this would be like, hey, if you're on the surface of the Earth, what's the angle the light's coming in at? All right. And so we got the Arctic Circle, we got Detroit, we got the equator, and then here we have 23.5 degrees south. Okay. So we're going to just draw these angles. Now, the nice thing about Cami, guys, watch this. I'm going to go to insert line. I'm going to make sure that I have a real thick line. All right. I'm going to use yellow because we're doing photons of light. Now, if I'm standing on the 23.5 degrees south latitude line, I have an angle of insolation. That means the angle that the light is coming in is 90 degrees. So I'm going to draw a photon of light moving straight up and down, hitting the surface of the Earth. Okay, boom. All right, so that's a 90-degree angle. It's hitting the Earth straight up and down. Now, if I go to the equator, right here, it's not straight up, right? It's tilted a little bit. So I say tilted to the right, it's at a 66.5 degree angle. So I can do this. Now, I want you to cross the surface, right? So that the line that the two, that's close enough. Okay. So this is a 65 degree or 66.5. What angle did I do? Did I do 65? I did 65. I want 66.5. Pay attention, everybody. All right. 66.5 is what I want. That's 66.6, close enough. All right. So this angle is 66.5. Right, and it's striking the surface of the Earth. Now, obviously, the photons of light don't go into the Earth like this, but we're limited with Cami on how we can do this. Okay. Then let's just do one more here. We'll do Farmington Hills. It's 24-degree angle, right? 24. So I'm going to start way over here, and I'm going to have a real shallow line going down like this. Okay, and then I'm going to make sure it crosses the Earth, the surface of the Earth. Perfect. Okay. Now, so this angle between the surface of the Earth and the photon of light, right? That's the angle of sunlight. Now, here's the whole point of this. This is what I want you to really get out of this, right? I'm going to go back to a smaller thickness of the line. What I want you to notice is this one photon of light is now stretched out over this much surface area, right? Because this low angle, the photon of light gets stretched out. And that's not going to provide a lot of heat for the surface because it's such a low angle. It gets spread out over a larger surface area. So that's less heat per square inch. It's not going to heat the Earth very well. But meanwhile, over here, when you have it straight up and down, it perfectly hits the ground and it's going to transfer more energy to the surface, right? Compare that to the equator, which is kind of more like in the middle, right? Slightly bigger than this right here. All right. So you got one more to do. You got this one, and then you're going to do all these other examples, and then there's going to be some questions in class. So, folks, enjoy.